my name is Aaron Gui Hong Yi, and today I'll walk you through the IPv6 configuration of our TCN6213 computer networks project. So before I start, I would like to introduce my group members, who are Ganshen Qi, Tan Wai Ming, and Liu Chen Wei. Okay, so the IPv6 configuration part is a crucial part of our network setup, which ensures efficient communication across different subnets. So let's get started. Okay, so for this project, we designed an IPv6 addressing scheme that allocates unique subnets to different sections of our network. So now I will show you our IPv6 prefix. So for IPv6 prefix, it is 2034, 1111, and 1959, and /64. So these four numbers are the static numbers that will not change. And then the rest of the numbers are the auto-assigned IPv6 address. So before we get into that, I'll first talk about the static IPv6 address. So for the static IPv6 address, we use it on the server part. So let me choose a device. Okay. So when we go to IP configuration, we can see that in IPv6 configuration, we select static, and then the IPv6 address is manually typed in by us. So for the server part, we don't use DHCP to auto assign the IPv6 address. So for every single device, we manually type in the IPv6 address. Okay. So that is our static IPv6 configuration. So now let's move to our DHCP configuration of our device. So I'll go down here. Okay, so it's here. Okay, so as you can see, these are the commands that we use to configure our DHCP. So for example, here address prefix 3034.11959. So we set the prefix for this device as our prefix, and then for every device, we assign a number to it, a special number to it. So in this case, this main router is 4, and then yeah. So I'll show you at which part. I'll show you where it assigns an auto IPv6 address. So for example, I'll open this PC, and then go to IP configuration, and then it will show the static prefix for the IPv6 address 2024.111.1959, and then 6 indicates that every PC here uses 6 as the fourth IP, and then it will show IPv6 request successful. That means that the rest of these, it will be auto assigned by the DHCP configuration. Okay, so to prove that our configuration is successful, I will now ping to the web server by using a random PC. So before that, I have to copy the IP of the web server, and then I will choose a random PC. And then let's go to the command prompt, and let's ping. And it should show a response. Okay, it says that there is a reply from this IPv6 address. So that means that we successfully configured our devices and we get a response from the web server. So that's all for my part. I will pass on to my teammate for the next part. Thank you.
Hi, my name is Ganshen Qi, and now I will present about the ping for our project. So to ping the PC, we need to open the PC, either lab 1, lab 2, and admin PC, tutor PC, or classroom PC. So we try it one by one. So I will open the lab 1 PC first. I will try to ping the let us choose one, which is I choose the admin PC here. So to ping the PC, we need to open the command prompt. We choose the let1 PC3 to ping, and to ping the address, we need to obtain the admin PC address first. So we need to open the IP configuration to know which IPv6 address is, then we can start pinging now. So we type ping and the IP address.
A few moments later.
So this is the IP address of the admin 4 PC, and I will ping the address from let1 PC3 to admin 4 and enter. So this is the pinging process, and you can see the result is successful. So let us move on to the next one, which is the lab2 PCs. I will choose either one, and as an example, I choose the lab2 PC1 for the pinging process. And as usual, we open the command prompt, we choose either one, I choose the lab1 PC instructor, and to ping, we need to know their IP address. Sorry. So type ping
A few moments later.
and enter, and it will start pinging the IP address. So we need to wait for a while, and as you can see, it's also successful for the lab2 PC to the lab1 instructor. So let us move on to another, which is the admin PC. So we choose the admin PC1 for the pinging. Then we will try to ping to the class PC. So we choose class 4 for the ping process. So need to obtain the IP address first. So ping,
A few moments later.
and we press enter. We will start pinging the process, and it is also success. And we move on to the next one. So which is I will try to ping the tutorial PC. So I will choose the tutorial PC6 for the pinging process. Then I will try to ping the lab PC, like PC20 from lab 2. So as usual, obtain the IP first and start pinging. Then we press enter, and it will start pinging, and we wait for a while for the result, and also successful for the tutor PC to lab PC. So moving to the last one, which is the classroom PC. So we will try to ping, like we choose the class PC, ping to system admin PC. So we choose class 3 to ping and open the system admin PC to obtain the IP address and start ping,
A few moments later.
and enter. Also successful, and that's all for me. Actually, that are another ways to try the ping. You can click this and either one, like PC instructor to system admin PC, and it will show the result here, and which is also successful, as you can see on the PDU list window. Okay, so that's all for me. Thank you.
So now I will demonstrate the accessibility for our web server, file server, and cloud server. So now in the first, we will go to the web server, click on the PC, and we'll go to the desktop, and go to the web browser, type mu.edu.my and press enter, and we show the result. So this is for our web server. So now we will continue to the class server, and also we click on the PC, and we go to the command prompt, and we type TP.
12 seconds later.
The username we will use admin, and the password also use admin. So we will show the login successful. So we type the dir, enter. Okay, so then it show the text lah. So we close this first, and we go to the text editor, and we write something. Okay. So we save this file, we name as test file.txt. Okay, and go back to the command prompt, and we write put test and press enter. So we will transfer complete. Okay, so we type back dir, and we will show our text file in this way. So we also can try in other computer. Also come to command prompt. So we can use get as far.txt. We also will transfer complete. We type dir. So it will also show the text file in this way. So now we will go to the last is the cloud server. And we go to the PC, also in the command prompt, and we click this first, and we use pin.
A few moments later.
Press that out. So because we cannot access, because the computer has not access on the ISP, so it will show the request hangout.
Hello everyone, my name is Wai-Ming, and today I will be discuss about an overview of our network topology for this project. My discussion will cover both the physical and logical topology. So first, we can see on the logical topologies. So as you can see, we selected a star topology as our primary structure due to its reliability and ease of troubleshooting. The logical topologies was structured using subnetting and an IP addressing schema that allow efficient data transmission. Key elements include subnet allocation, which can dividing the network into segments for better organization and security. Then next is the router configuration. Router configuration can implementing dynamic routing protocols such as OSPF v3 to enable seamless communication. So last one is the DHCP v6 deployment. So for the DHCP v6 deployment, we can automating IP address assignment for connected device. So this logical design ensure that network traffic is efficient managed, reducing congestion and improving overall performance. So next, we can see on the physical topologies. So for the physical topologies, you can see on the screen, more of the devices are connected by cable, and less of the devices are like PC and laptop are not connected by the cable because they are connected by wireless Wi-Fi. And then for the physical topology, refer to the actual arrangement of hardware device and cable in our network. This setup include router, switch, and access point. So the function of router is serving as the central node for the connectivity, and next for the switch is facilitating the efficient data transfer across the network. Then last one, for the providing wireless, for the access point, can providing wireless access to end device. So here's the cabling. We're using the Cat6 Ethernet cable for high-speed connection. So by carefully organizing this component, we ensure optimized performance, scalability, and minimal latency. So that's all for my part.